Imagine a swirling cloud of dust and gas, remnants of a supernova explosion. This is the raw material from which planets are born, a chaotic mix of elements scattered across the cosmos. Over millions of years, gravity pulls this cosmic debris together, slowly but surely. The particles begin to coalesce, drawn by the invisible force that governs the universe. The particles collide, generating heat and energy. These collisions are not random, they are the building blocks of a new world, setting the stage for the formation of a planet. Slowly, a fiery ball begins to form. This is the nascent Earth, a glowing orb of molten rock taking shape in the vast expanse of space. This is Earth in its infancy, over 4.5 billion years ago. It is a hostile environment with temperatures soaring and the surface in a constant state of flux. As Earth cooled, its molten surface solidified, forming the first rocks. These rocks are the foundation of our planet, the first solid ground in a world of fire and chaos. Volcanic eruptions spewed gases from the planet's interior, creating a primitive atmosphere. These eruptions were frequent and violent, shaping the early landscape. This early atmosphere was very different from the one we breathe today, lacking oxygen and dominated by carbon dioxide, methane, and ammonia. It was a thick, toxic mix, uninhabitable by modern life. Through a process called differentiation, the heavier elements like iron and nickel sank towards the center, forming Earth's core. This core is crucial, generating the magnetic field that protects us. Lighter elements like silicon and oxygen rose to the surface, forming the crust. This crust is the outer shell of our planet, a solid layer that supports life. This separation into layers is crucial for Earth's dynamic systems, including the magnetic field that protects us from harmful solar radiation. Without this field, life as we know it would not be possible. The early Earth was a violent and chaotic place, bombarded by asteroids and comets. These impacts were catastrophic, reshaping the surface and delivering essential materials. These impacts delivered water and other essential building blocks of life. Comets and asteroids brought not just destruction, but also the ingredients necessary for life to begin. As the bombardment subsided, Earth began its journey towards becoming the vibrant, life-sustaining planet we know today. The stage was set for the emergence of life, a process that would take millions of years. The early atmosphere was a toxic mix, unsuitable for life as we know it. It was composed mainly of gases like methane, ammonia, and water vapor, with very little oxygen. This harsh environment was dominated by volcanic activity, releasing even more toxic gases into the air. But within this primordial soup, a remarkable transformation was about to occur. The combination of these gases, along with energy from lightning and volcanic activity, created the perfect conditions for the first organic molecules to form. The first life forms, simple, single-celled organisms, emerged in the oceans. These microorganisms were the pioneers of life on Earth, thriving in an environment that would be hostile to most modern life forms.
These early microorganisms, called cyanobacteria, possessed a remarkable ability photosynthesis. This process allowed them to harness the energy of the sun to produce food, a revolutionary development in the history of life. Through photosynthesis, cyanobacteria used sunlight, water, and carbon dioxide to create energy, releasing oxygen as a byproduct. This not only provided them with the energy they needed to survive, but also began to change the composition of the atmosphere. This process gradually transformed the atmosphere, increasing oxygen levels and paving the way for more complex life forms to evolve. Over millions of years, the oxygen produced by cyanobacteria accumulated in the atmosphere, leading to what is known as the Great Oxidation Event.
The rise of oxygen in the atmosphere had profound consequences. It not only allowed for the development of aerobic respiration, a more efficient way for organisms to produce energy, but also led to the formation of the ozone layer. It led to the formation of the ozone layer, a protective shield in the upper atmosphere that absorbs harmful ultraviolet radiation from the sun. This shield was crucial for protecting emerging life forms from the sun's damaging rays. This allowed life to move out of the oceans and onto land, leading to the diversification of life on Earth. The protection offered by the ozone layer enabled organisms to explore new environments and adapt to different conditions. The evolution of the atmosphere is a testament to the interconnectedness of Earth's systems. The changes in the atmosphere influenced the development of life, and in turn, life influenced the composition of the atmosphere. The emergence of life, specifically photosynthetic organisms, fundamentally altered the planet's chemistry, creating the conditions necessary for the evolution of more complex life, including ourselves. This intricate dance between life and the environment continues to shape our planet to this day. Covering over 70% of Earth's surface, the oceans are a defining feature of our planet. They are vast, mysterious, and hold many secrets yet to be uncovered. The sheer expanse of the oceans is a reminder of the power and beauty of nature. They play a vital role in regulating climate, absorbing carbon dioxide, and supporting a vast array of life. The oceans act as Earth's lungs, breathing in carbon dioxide and releasing oxygen, making life on land possible. They're also a major source of food and livelihood for millions of people around the world. But the oceans were not always as we know them today. Over billions of years, they have undergone dramatic changes, shaping the course of life on Earth. From the ancient seas that harbored the first life forms to the modern oceans teeming with biodiversity, their evolution is a story of resilience and transformation. The early oceans were formed by the condensation of water vapor released from volcanic eruptions and delivered by comets. These celestial events brought the essential ingredient for life to our planet, setting the stage for the development of complex ecosystems. These early oceans were likely acidic and hot, but as Earth cooled, they provided a stable environment for life to emerge. The cooling process allowed for the formation of more complex molecules, eventually leading to the first simple organisms.
The oceans are not a static body of water, but a dynamic system driven by currents, tides, and temperature variations. These movements create a constantly changing environment, influencing weather patterns and the distribution of marine species. These factors influence the distribution of nutrients and marine life, creating a complex and interconnected web of life. The ocean's currents carry nutrients from the depths to the surface, supporting a diverse range of organisms, from tiny plankton to large predators. From microscopic plankton to giant whales, the oceans are teeming with life. Each species plays a crucial role in the marine ecosystem, contributing to the delicate balance that sustains life in the ocean. They are home to the largest animal ever known to have existed, the blue whale, and countless other species, many yet to be discovered. The depths of the ocean remain one of the last frontiers of exploration, with new species being discovered regularly. The oceans are a testament to the power of life to adapt and thrive in diverse environments. From the sunlit surface waters to the dark, cold depths, life has found a way to flourish in every corner of the ocean. This adaptability is a testament to the resilience and ingenuity of life on Earth.
Section 4. Shifting ground, the dance of tectonic plates. Beneath Earth's surface lies a hidden layer, the mantle, a layer of hot semi-solid rock. The heat from Earth's core drives convection currents in the mantle, causing the tectonic plates, massive slabs of Earth's crust, to move. This movement, known as plate tectonics, is responsible for shaping Earth's surface over millions of years. The collision of plates creates mountains, while their separation forms valleys and ocean basins.
The movement of tectonic plates also plays a crucial role in regulating Earth's climate. Volcanic eruptions release carbon dioxide into the atmosphere, contributing to the greenhouse effect. However, over geological timescales, tectonic activity also removes carbon dioxide from the atmosphere through the weathering of rocks and subduction, where one plate slides beneath another. This balance between carbon sources and sinks helps regulate Earth's temperature. The constant movement of tectonic plates is a reminder that Earth is a dynamic and ever-changing planet. It is this dynamism that has created the diverse landscapes and habitats that support life on Earth. Section 5. The circle of life, carbon and water cycles. Life on Earth is sustained by a delicate balance of interconnected systems, constantly cycling essential elements like carbon and water. These cycles are crucial for maintaining Earth's habitability. The carbon cycle involves the movement of carbon between the atmosphere, oceans, land, and living organisms. Plants absorb carbon dioxide from the atmosphere through photosynthesis, converting it into organic compounds. This carbon is then passed on to animals when they consume plants or other animals. The water cycle is equally vital, involving the continuous movement of water between the oceans, atmosphere, and land. Water evaporates from the oceans and other water bodies, forming clouds. Precipitation returns water to the land, where it flows into rivers, lakes, and eventually back to the oceans. These cycles are not independent, but interconnected. The water cycle is essential for transporting nutrients and shaping landscapes. The carbon cycle relies on the water cycle for the transport of carbon dioxide and the weathering of rocks, which releases essential minerals.
Section 6, A Tapestry of Life, Ecosystems and Biodiversity. From the lush rainforests to the icy polar regions, Earth is home to an astonishing array of ecosystems, each with its unique combination of climate, soil, and life forms. These ecosystems are not isolated, but interconnected, forming a complex web of life. Biodiversity, the variety of life on Earth, is essential for the health of ecosystems and the planet as a whole. Different species play different roles in an ecosystem, contributing to nutrient cycling, pollination, and pest control.
For example, in a forest ecosystem, trees provide habitat and food for a variety of animals. Insects pollinate flowers, ensuring the reproduction of plants. Fungi decompose dead organic matter, releasing nutrients back into the soil. This intricate web of life is the result of billions of years of evolution, a testament to the power of life to adapt and thrive in diverse environments. However, this delicate balance is under threat from human activities.